So let's begin. Force. So force is actually a topic that you already have learned in form 2 science. Force in kalau bahasa Melayu dia ialah daya. And so we know what force is. If you remember what you studied in form 2, force is something, and what it does is that it can do things such as it can move things, it can change the shape of things, it can make things turn in a different direction, go faster or go slower. So you know what force is. Now in Form 4, this is when we study what force actually is a little bit more in depth. So let's look at Newton's second law of motion. Newton's second law of motion states that the rate of momentum is directly proportional to the force and acts in the direction of the applied force. Alright, so we learned what is momentum last week. Okay, momentum is a mass times velocity. Now force, so if momentum is mass and velocity, force is mass and acceleration. Yeah. So for there to be force, there has to be some sort of acceleration. There has to be some sort of change in speed. Now, the famous formula that is usually given is this. Force equals mass times acceleration. F equals ma. But I want to show you something. There is another formula that sometimes is not so clearly written. So we have force, and we know that equals mass times acceleration. Okay, so far so good. Nothing too complicated. Right? Now, mass, we know what mass is. Okay? Mass is m, a is acceleration. Sometimes, in some questions, they do not give you the acceleration in the question. Sometimes what they give you is this. Sometimes you have to use this formula. They give you the velocity. They give you final velocity. They give you initial velocity, and they give you the time. So in those circumstances, or in that situation, when they don't give you the acceleration, but they give you velocity and they give you the velocities and the time, then what we can do is we can substitute this formula. So earlier in the chapter, we learned that acceleration equals what? Acceleration equals final velocity minus initial velocity over time. This is not new. You've learned this before in the past. So what we can do is we substitute. So this is 1 and this is 2. So this is number 1, this is number 2. What we can do is we substitute. So what we can do is substitute number 2 in number 1. So instead of F equals ma, we put F equals m. We substitute the a with this formula. V minus u over t. Alright? We can simplify the formula, or we can rewrite the formula like this. Force equals mv minus mu over t. So, actually, there are two formulas that you need to know and understand. So the two formulas that you need to understand for this chapter is this one. Force equals ma. So you need to know this formula. Wait. You need to know this formula, but you also need to know this formula. This formula is, it just comes from this formula, bane. Right? So actually, if you understand this formula, then you can sometimes just use this one and then calculate the acceleration separately. But if not, you can just use this one instead. All right. You'll understand better when I show you the examples. So let's go back to this question. So for forced, we always use the formula force equals mass times acceleration. So let's do a couple of examples. Now, if you have your textbook, you'll find the same example in page 66. So you can read the answer for yourself over there, but I'm going to show you how to do it step by step. All right, so let's read the question. So a worker pulls a load of mass 80 kilograms along a horizontal force of 160 newtons. So they already give you the force in this question. If the surface is smooth and without any resistance that opposes the motion of the object, what is the acceleration of the load? So if we look at the question is asking for the acceleration. So acceleration is not stated. So acceleration is unknown. Mass is stated as 80 kilograms. And force is 160. All right. So let's solve this. So very simple. You've already calculated all the things that you need to know. You have acceleration, you have mass, and you have force. Just use the formula. So force equals mass times acceleration. And remember, we want to find acceleration, so we can rewrite the equation as acceleration equals force divided by mass, like that. And so force is 160 newtons, mass is 80 kilograms, and so you get your final answer of 2. So 2 meters per second. So just that's how you use the formula. Very simple. So for example number 1, it's quite simple. It's quite straightforward. Not much to solve. I'll send you the slides later with the solution, but it's already in your textbook actually. Okay, so that's the first example. Let's try another example. So this is an example of a question where the acceleration you just need to find the acceleration. Now, question number 2, or example number 2, here is an example of a question where you do not have the acceleration. Yeah? If you read the question, the acceleration is not given anywhere. It only gives you a initial speed, a final speed, it gives you the mass, and you need to calculate the force. So, let's try with that question. So let's read the question. A car of mass 1,200 kilograms moves with a velocity of 30 meters per second. So we know the initial velocity is 30. When the brakes of the car are applied, the car stops in 5 seconds. So the time it takes is 5 seconds, and calculate the average braking force of the car. So go back to our whiteboard. Let's see what information is already stated in here. So let's see what we have. What do we need to look for? We need to find the braking force. So force is unknown. We do not know how much is the force. All right, next. Okay, mass of the car is 1,200. So mass is 1,200 kilograms. Next, initial velocity U. Initial velocity is 30. So let's put that in. U equals 30 meters per second. Next, final speed. Now it doesn't say the final speed, but it says that the car stops moving. So if it stops moving, then our final speed must be 0. So V equals 0. And then the last thing is the car stops in 5 seconds. So time is 5 seconds. Time is small letter t, 5 seconds. Okay, so now we have all the information out here complete. So now what we can do is, there are two ways for us to do this. Either we do this in 2 steps or we do it in 1 step. So whichever way you want to do it. So if you want to do it in 1 step, let's start with 2 steps. So 2 steps. So step 1. So for step, that's too far. So for step 1 is we need to calculate acceleration. Alright, we need to find acceleration because the question does not give us the acceleration. So we'll use the formula for acceleration. A equals, you know this by now, so final speed is final speed minus initial speed over time. Alright, so 0 minus 30 over 5. And so we get our final answer of, what is it? Negative 30 divided by 5 equals negative 6 meters per second. Okay. Now, once we know the acceleration, now we can go to step 2. And in step 2, we will use F equals ma. Force equals mass times acceleration. Alright, so we know mass, we already wrote down just now, mass is 1,200. Acceleration is negative 6. And we get our final answer as, let me just move that a bit. And so our final answer we end up getting is negative 7,200. So this is a longer way. What I'm doing in this way is I'm doing it step by step, right? So I find acceleration first, and then I use that and put it in this formula. Now, that's one way to do it. And you notice that my answer, I should explain. The answer is negative 7,200 because remember the car is stopping. The car is going slower. The force is going in the opposite direction of the movement of the car, right? So since it's going in the opposite direction, we use it as a negative. I should explain. Force is a vector quantity. So there's direction. So you need to take into account the direction. So this is method 1. This is method 1 of solving the question. Now, if you want to do it faster, what you can do is, instead of doing it step by step, you do it in one go. Right? So you do it in one go. You go, force equals mass times acceleration. And you put the formula for acceleration right here. Force equals mass times acceleration. So V minus U over T. So you put it directly in here. Force equals mv minus mu. Sorry, I need to make that clear. mv mu over T. And if you try it out, you'll see you get the same answer. So mv, mass times final velocity. Final velocity is 0. So we'll put 0 minus mu. So m is what? M is 1,200. U is 30. So you get 36,000 divided by 5. And you still end up with the exact same final answer of negative 2,000 newtons. So either way, you can do the examples either way. Either you find the acceleration first, then use force equals mass times acceleration, or you substitute the acceleration in this first formula and do it all in one go, whichever you feel more comfortable with doing. I just want to show you that there are different ways of doing it. In physics, there's always going to be, in physics, it's almost going to be 2 or 3 different ways to do the same question. And so what you need to do is to find the way that works best for you. That's why it's really important for you to practice. All right, so that's it for force. Now, let's go to the next topic. So once you understand what force is, then we can go on to learning what is impulse and impulsive force. So impulse and impulsive force has to do with when there is a change. When there is a change in momentum. Basically, when something gets faster or gets slower, there is a certain amount of force involved. And we call that as impulse. So, impulse is a change of momentum. Okay, and we use J. So J equals mv minus mu. So mv minus mu, we just looked at that just now. Right? mv minus mu, or sometimes it also is ft, where f is force and t is time of the action of the force. So, to give an example of where there's impulse, in your textbook, it uses the example of someone jumping, long distance jump. Now, what happens when a person jumps? When he or she jumps, you run forward, right? That's how they do it in track and field. You run forward, and so you're going quite fast, and then you jump. And you're still moving. And then, when you land, you suddenly stop. So you go from, I don't know how fast a person can run. Maybe you're running at maybe 10 meters per second. You're running at 10 meters per second, and then you go from 10 to 0 in like 1 second. And so because your speed changes so fast, it also changes your momentum very fast. Your momentum changes. And so there's what we call an impulse. There's a force that happens when you slow down. Or basically when you slow down. Usually impulse, it's either getting slower or getting faster. That's why when you have an accident, when someone is driving, it's not the speed that kills you. Yeah, when you have an accident. There's a saying, it goes, it's not the speed that kills you, it's stopping suddenly that kills you. Because when you stop suddenly, there's a huge amount of impulse force happening. Alright, so the formula for that is this. Alright, so that's impulse. Now, impulsive force is the rate of change of momentum in a collision or impact in a short period of time. So, impulse is the change of momentum. That's what impulse is. Impulsive force means how fast does the change happen. Okay? If I were to stop a car and I'm going at 60 kilometers per hour and I press the brakes slowly, the car also stops slowly. The change of momentum is slow, right? And when I change it, so the rate of change is very slow. You notice that when you slow down the car, it doesn't move so much. You slow down slowly. But if you're driving and you suddenly hit the brakes, you notice what happens, right? Everything moves because the rate of change of momentum is very high. The impulsive force is very high. So If the impact time is very long, then you get a lower impulsive force. If the impact time is very short, you get a higher amount of impulsive force. All right? So what's important is you understand this formula. So the important thing is you understand these two formulas. You understand how to calculate the impulse, which is the change of momentum, and you understand how to calculate the impulsive force. By the way, just to clarify, the unit for impulse your unit is Newton seconds. It's not very blue is not a very good color for this. Let's try red. Okay, Newton, that should be better. Okay, so Newton seconds. So this is for impulse. Newton seconds. And impulsive force. Impulsive force is you just use Newton as unit. For force, you usually use newtons, right? All right, let's do a couple of examples. So, first question. Example 1, this is on page 69 in the textbook. A plasticine ball of mass 0.058 kilograms is thrown at a velocity of 10 meters per second and hits the wall. It sticks to the wall. What is the impulse of the plasticine? So the question is asking for impulse. So how do we solve that? First, we need to first let's look at what information we already have. All right. So plasticine ball. Okay. So mass is stated to be 0.05 kilograms. 58 kilograms. So that is the mass of the plasticine ball. Next, the velocity. Okay. The initial velocity, final velocity is 10. Initial velocity is 10. Initial velocity is 10 meters per second. Final velocity, it doesn't say, but it says it hit the walls and it sticks to the wall, which means it stops. So our final velocity is 0. Final velocity is 0. And finally, so that is the only information that is given. And finally, the question is asking for the impulse, or basically J. So it's not stated what the impulse is, so we need to find it. So we've learned the formula just now. Okay, so this is the formula that we're going to use. So what you're going to use, J equals mv minus mu. Right? So mv came 0.058 times 0 equals 0. Actually, let me just write it out. 0.058 minus 10, 0.058. Okay? So 0 times 0 times anything equals 0. So 0 minus, so 10 times 0.058 equals 0.58. So final answer is negative 0.58 newtons. So very simple, not much to it. There's really no other way to do it. That's basically it. It's negative because the ball is stopping, it's getting slower. So it's a negative. The amount of momentum it's a negative. It's getting slower, right? It's going in the opposite direction. Okay. If it gets faster, then it would be positive, right? So that's the first example. Second example. a golfer hits a golf ball of mass 45.93 at a velocity of 50 meters per second. If the impact time is 0.05 seconds, what is the impulsive force acting on the ball? So in this question, the golf ball starts at 0. Well, let's go through the steps as usual. So golfer hits a golf ball of mass. So mass is stated clearly as 45.93. That's the mass. And the velocity is 50. So it starts at 0. Your initial speed is 0 because the golf ball is on the ground. And then your final speed is 50. The impact time, meaning to say, the impact time of the golf club on the golf ball is 0.005 seconds. So time is 0.005. And the question is, what is the impulsive force? So you need to find the force, which is not stated. So this time we're going to use the formula for impulsive force. So formula for impulsive force is this one. We've studied that already. Alright, so we just go and write it out. So force equals mv minus mu over t. And we just put all the information in. Alright, mv, okay, so 45 times 93 times 50 minus, well, m is 45, but u is 0, so it's going to be 0. So minus 0 basically. Time is 0.005. Alright, and if you calculate everything on the calculator, you get a final answer of 459.3 newtons. Okay, you can use a calculator to help you with that. Alright, those three are all basically connected with each other. Okay, last one. I should say last topic. So we've taken a look at force, impulse, impulsive force. It's all related actually. And the last one is, wait, yeah, okay. The last one is weight. Weight, I don't need to explain because you already know what weight is. Weight is the mass of an object times gravity. Right? So you study this in form 2 again. It's in form 2. Weight ataupun daya berat. Weight is just another type of force, right? It's just that this time, let me show. Weight is exactly the same as force. Cara kau kira sama saja dengan cara kamu kira force. So force equals mass times acceleration, right? Weight is just mass times the acceleration of gravity. That's all it is. It's basically the same thing. Okay? So weight, if you're timesing it with acceleration left or right, then that would be force. But if the question is asking about acceleration towards the ground, towards gravity, then it's weight. But other than that, the way you calculate weight and force is exactly the same. If you know how to calculate force, then you can calculate weight. Okay? The only other thing you need to know is gravity for most questions, if you are on Earth, kalau kamu di bumi, then gravity is always, I think I told you this before, 9.81 meters per second. That's always going to be gravity. Kalau soalan itu suruh kamu kira weight, tapi dia tidak bagi kamu dia tidak bagi kamu dia punya gravity, then automatic kamu anggap saja gravity is 9.81. Unless the question says that you are on a different planet. Okay, if the question says you're on a different planet, then usually the question will give you the gravity. Right? Like if you're on, I don't know, on the moon, then you'd have a lower value for G. If you're on a bigger planet, like say Jupiter, then you'd have a bigger value for G. But if you're on Earth, then usually you just assume that gravity is 9.81. Okay. Now, the only thing that you need to be careful when you're reading questions about weight is you need to read the question carefully, because in physics it's a little bit different from how it is when we are just talking. Normally, when we go to someone, yeah, ini kebiasaan kita. Kalau kamu jumpa orang, and then kamu tanya itu orang, berapa berat kamu? How heavy are you? Apa yang kita jawab? Kita selalu jawab dalam bentuk kilogram. So let's say, kalau kamu tanya Sir, berapa berat kamu? Oh, I am 60 kilograms. Okay, in English we say my weight is 60 kilograms. Okay, in physics that's wrong. Okay, in English it's fine, but in physics that's wrong. You do not use kilograms. It does not tell you your weight. Kilogram only tells you your mass. Dalam bahasa Melayu jisim. Itu dia hanya bagi tahu kamu punya jirim. So read the questions carefully. Okay, my mass is 60 kilograms, but my weight is 60 times 9.81 equals, what is that? Let me check the 588.6 newtons. So my mass is 60 kilograms. This is physics, not English. My mass is 60 kilograms, but my weight, because weight you have to times it with gravity, is 588.6 newtons. Weight is always in newtons. Okay, mass is in kilograms. The reason why this is important is because your weight will change when you go to different planets or to places with different gravity. So if I go to the moon, let's say satu hari nanti kita bernasib baik, Elon Musk sudah siap cipta dia punya kapal terbang, sudah dia mulai jual tiket untuk melancong ke bulan. Okay? When I go to the moon, my mass will still be the same. Jisim dalam badan saya tetap 60 kilo. But because the gravity on the moon is lower, my weight will be lower. My weight would only be maybe half of this. Maybe only 300 newtons or 200 newtons. So you need to understand the difference between weight and mass. So when you read the questions, when you read any questions about weight and mass, you have to read it carefully and make sure that you're answering the correct one. Is the question asking for the weight or for the mass of an object? Okay? So now basically, now that we've gone through these 3 topics, you are done with chapter 2. Finally. Such a long chapter. It's been a long chapter. Okay, does anyone have any questions so far about any of the topics that we've gone through? Any questions that you'd like to ask here or in the chat? Okay. So I know I'm moving a bit fast. I have to move fast. We have no choice but to move fast. All right. So in that case, If you have no questions, anyway, you can ask me later if you have questions. Okay, so now what I want you to do then, for your for the rest of the class, you still have, what's that? 30 minutes left, more than 30 minutes left. Okay, let me just stop the recording first.